So in last lab we studied about the SR flip-flop, or you can say SR latch. Now today we have to perform the experiment of the, you can say, a JK flip-flop, D flip-flop, T flip-flop, and again it is a SR flip-flop. But there is a difference between a latch and a flip-flop. Generally in latch what we have to do, we are not providing any clock pulses, or you can say in other terms it is a enable pin. Okay, it is a enable pin, so we are not providing the enable pin. So now today we are studied about the flip-flops which having a enable pin. So let me share my screen. Okay, so again we are performing the experiment in the platform of the online, which is a virtual lab designed by the IIT Bombay, and these are the list of experiment. So generally now I think we have only two or three experiment is pending. The first experiment, the verification and the interpretation of the truth table of AND or NOT gate. So the basic gates we already covered. We also covered the half header, full header, and the half subtractor, full subtractor. We also covered the universal logic like a NAND gate and NOR gate, which is work as a universal gate, and construction of null gate latch and verification of its operation. So this is the experiment number 5, which we are performing in the last lab session, which is a SR flip-flop, or you can say a set. What is the meaning of SR? The S means set and R means reset. Wait for the 1 minute. Sorry. So we are performing the SR flip-flop. Okay. We also cover the decoder, demultiplexer, and encoder, demultiplexer, multiplexer, gray to binary conversion, and the comparator. So now we have just performed counters. We have to perform the pending experiment is counter, 4-bit serial in and serial out, or parallel out. After this experiment, today we have to perform the experiment number 6, which is the verify the truth table of RS, JK, T and D flip-flop using NAND and NOR gates, using NAND gate and NOR gate. So today we have to perform the, again we have to verify the truth table of the following flip-flops. So actually we have four flip-flops, basic four flip-flops, which is RS, JK, T and D. RS, JK, T and D. Okay, so today we have to perform this experiment, which is verify the truth table of RS flip-flop, JK flip-flop, T flip-flop and D flip-flop by using a NAND gate and NOR gate. So generally flip flops are made by the NAND gate and NOR gate only. So we are not using any another gate for the flip flop. Okay, mostly we are using the NAND gate and NOR gate as a flip flop. NAND gate and a NOR gate as a flip flop. So this is the aim. What is the aim of the experiment? The aim of the experiment is to verify the truth table and timing diagram of RS, JK, T and D flip flop by using a NAND and NOR gates IC and analyze the circuit of RS, JK, T and D flip flop with the help of LED display. So that's our experiment. So going into the theory, okay, so this is the thing which we are performing in last lab. You can say the SR latch or SR flip flop, and it is made by the NOR gate. Okay, it's not compulsory that SR flip flop is are made by the only NOR gate. It's also made by the NAND gate. So in same figure, instead of NOR gate, you have to put the NAND gate. Let me show you. So okay, you can also use the NAND gate instead of NOR gate. Okay, so this is the figure of the SR flip flop only. This is the figure of the SR latch only, but by using the NAND gate, by using the NAND gate. Okay, so now if we are changing the gate, okay, instead of NOR gate, now I am using the NAND gate. So there is some change in truth table also. There is some change in truth table also. You can also verify that by using yourself. Okay, now today's experiment, generally we are using the NAND gate only. Okay, today's experiment generally we are using the NAND gate only. Now, what is the change in table when we are using a NAND gate? So let me write down the change in a table here only. Okay. So what is the difference when I am using the NAND gate instead of NOR gate? Okay, suppose I am using the NAND gate instead of NOR gate. So what is the difference in a truth table? So if I am using a NOR gate, if I am using the NOR gate, then when my SNR 00, when my SNR 00, do not focus on the QN, then my state is no change. Then my state is no change. But suppose instead of NOR gate, if you are using the NAND gate, so at the moment of SNR 00, instead of no change, it is replaced by the invalid. It is replaced by the invalid, and at the state of 1 1 of NOR gate, at the state of 1 1 of a NOR gate, it comes when we are using the NOR gate, the state is invalid. When my SNR is 1 1, my state is invalid. But instead of that, now if suppose I am using the NAND gate, so at the moment of NAND gate, I am using 1 1, the state is no change. So no change and invalid states are interchanged. No change and invalid states are interchanged. Let me again define you. Suppose the same thing when we are using the NOR gate. Suppose we are using the NOR gate and my SNR 00. So when my SNR 00, at that moment, when my SNR 00, at that moment, we have a state no change. We have a state no change. But instead of that, suppose if you are using the NAND gate instead of NOR gate, NAND gate instead of NOR gate, then at the moment of SNR 00, then at the moment of SNR 00, my state is invalid. My state is invalid instead of no change. Instead of no change, and it is also replay affect the 1 1. So suppose if I am using the NOR gate, if I am using the NOR gate, and if my SNR 1 1, so when I am using the NOR gate and my SNR 1 1, then I have a state, then I have a state invalid, then I have a state invalid. But suppose instead of NOR gate, now I am using NAND gate. Instead of NOR gate, now I am using NAND gate, and if my SNR is 1 1, sorry, if my SNR is 1 1, so in a NAND gate, instead of invalid, now my state is no change. Now my state is no change. Okay. So this is the difference. This is the difference of a state. And suppose I am using the NOR gate. Suppose I am using the NOR gate and my reset is 1, or you can say R is 1. When my R is 1, my state is reset, and when my S is 1 and R is 0, my state is set. Again I am repeating, when I am using when I am using NOR gate, when I am using NOR gate and my S is 0 and R is 1, S is 0 and R is 1, so R1 means reset. So at that time my state is reset. At that time my state is reset. And when my S is 1 and R is 0, when my S is 1 and R is 0, my state is set. My state is set. But instead of NOR gate, suppose now I am using NAND gate. Suppose now I am using NAND gate. So same time, as no change and invalid is interchange, as no change and invalid is interchange, same way set and reset is interchange. Set and reset is interchange. So what will happen? So suppose now my S is 0 and R is 1. S is 0 and R is 1. At that moment my state is reset. But for which gate? NOR gate. But suppose I am using NAND gate, so these two is also interchange. So for R is 1, it is set, and S is 1 means reset. So this is the difference because the truth table of NOR gate and NAND gate is a different thing. The output of the NAND gate and NOR gate is different. That's why it is interchange. Okay, that's why it is interchange. So that is the difference in the truth table. That is the difference in the truth table. Okay. So today we have to learn about the you can say clock flip flop. It is clock the flip flop. So how it will be work? Clock flip flop, how it will be work? Let me show you the figure. Focus on the theory. Okay. So what is flip flop? You can see here the flip flop is an electronic circuit. Flip flop is an electronic circuit with two stable states. With a two stable states that already I said in the last lab we have two stable set which is set and reset. Okay, that's are the two stable sets. Generally, no change and invalid. No change and invalid are not considered in a stable state. Okay, so only two states are stable, which is known as the stable states set and reset. Set and reset is the stable state. And what is the use of the flip flop? The use of the flip flop is to store a binary data. To store a binary data, and that is already I told you about in last lab. Generally, one flip flop will store one bit. One flip flop will store one bit. Okay, suppose if you want to store 4 bit, then you require 4 flip flops. If you want to store 8, then you require 8 flip flop. For 1 bit, you require 1 flip flop. For 1 bit, you require the 1 flip flop. Okay, and the stored data can be changed. The stored data can be changed by applying the variable inputs. So suppose my qn is 0 and I am giving the command suppose my qn is 1 and I am giving to reset it. So if I am changing the input, then my output comes to 0. So either you want to store a 1 or you want to store a 0, you can set that. You can set that by changing the applying input. By changing the applying input. Okay. So flip-flops and latches are the fundamental building block of a digital electrical system in computers, communication, and many other types of system. Okay, computers in communication and many other types of system we are using the flip-flop. So it is a basic building block you can say. Okay, or fundamental digital block you can say. So we have a 4 types of flip-flop, which is known as the RS flip-flop, D flip-flop, JK flip-flop, and T flip-flop. RS, D, JK, and T. So now how it will be work? Let me show you. So this figure shows you the clocked SR flip flop, or you can say clocked RS flip flop. Clocked SR flip flop or clocked RS flip flop. So how it will be work? Okay. So as a clock pulse, for giving a clock pulse, what we are using for giving a clock pulse, we are using the, here you can say we are using the AND gate. So suppose if your RNS is 1 1, but without applying clock, suppose my clock is 0. So my output is always 0. As your RNS is 0 0, yours as your RNS is 1 1, then also if I am not applying the clock pulse, or if I am not giving the clock pulse, our flip flop will not work. So flip flop will not work when we are not giving the clock pulses. When we are not giving the clock pulses, because you can see as a clock pulse, at the input of the clock pulse we are giving as a AND gate. So if any one input of the AND gate will 0, if any one input of the AND gate is 0, then output is always remains 0. Then output is always remains 0. And when we have a NOR gate SR flip flop, when we have a NOR gate SR flip flop, and my input is 0 0, then my output state is, if you are remember, it is NC. NC means no change state. NC means no change. Okay. So if we are not providing the clock pulse, again I am repeating, if we are not providing the clock pulse, the flip flop will not change its states. Flip flop will not change its state. Okay. If it remains, if its output is 0, then it remains on the 0 states, and if its previous output is 1, then it remains on the 1 state, or you can say set state. Okay. So to change the state, to change the state of the flip flop, to change the state of the flip flop, what we have to do? We have to compulsory give here clock pulse. We have to compulsory give here clock, and clock, if my clock is 1, if my clock is 1, then and then output will be changed. Then and then output will be changed. If I am not giving the clock, if I am not giving the clock, my output will not change. If I am not giving the clock pulse, my output will not change. Okay, you have to remember this. So this is the figure of, you can say, it is known as the, it is known as the clock RS flip flop. So here the main application of clock is that sorry, the main application of clock is that without applying the clock, the output will remains in the state of no change. The output will remains in the state of no change. Okay, so this is the application of clock pulse. This is the application of clock pulse. Again, move to the theory. This one. So the basic NAND gate, the basic NAND gate RS flip-flop circuit is used to store the data. Is used to store the data. Okay, so it having actually a three input now. That three input is one is the set you can see here, another is reset, and the third input is clock pulse. Third input is clock pulse, and it having a two output. It having a two output Q and Q bar. It having a two output Q and sorry, two output Q and Q bar. So this is the generalized figure of the RS flip-flop circuit diagram. RS flip-flop circuit diagram with having a clock pulse, with having a clock pulse. Okay. Now this is the table. Suppose what is the meaning of cross? The meaning of cross means clock is not given. Clock is not given. So if clock is not given, either my what is SNR, it doesn't affect. If my SNR is 0, 0, if my SNR is 0, 1, if my SNR is 1, 0, and if my SNR is 1, 1, then also the output remains no change. The output remains no change, and its state remains previous state. Previous state means if my previous state output is 0, then it remains 0. If my previous state output remains 1, then it remains 1. Okay, so without applying the clock pulse, the output of the SR flip-flop, the output of the SR flip-flop will not change. The output of the SR flip-flop will not change. And suppose if we are giving the clock pulse, if we are giving the clock pulse, if we are giving the clock pulse, so at that moment, if my S is 0, at that moment, if my S is 0, at that moment, if my S is 0 and R is 1, if my S is 0 and R is 1, so it is known as the reset. It is known as the reset. And suppose I am giving the clock pulse. Suppose I am giving the clock pulse, and at that moment, if my S is 1, if my S is 1 and R is 0, if my S is 1 and R is 0, then this state is known as a set state. This state is known as a set state. And suppose if my S and R both are 1, 1, if my S and R both are 1, 1, then that state is known as the forbidden state, or you can say invalid state, or you can say indeterminate state. Okay, forbidden state, invalid state, or indeterminate state, anything you can say. Anything you can say, so this is the state. Okay, so without applying the clock pulse, it will not work. Without applying the clock pulse, it will not work. Now next one is the D flip-flop. Now what is the D flip-flop? Let me tell you about that. Suppose we have a SR flip flop only. Okay, suppose we have a SR flip flop only. So what are the states of the SR flip flop? Either S and R both are 0 0. When my S and R both are 0 0, my state is no change state. My state is no change state. And if my S and R is 1 1, if my SNR is 1 1, then my state is indeterminate state, invalid state, or you can say it is invalid state. Okay. So we have two states which we do not have its application. Either my SNR is 0 0, or you can say my SNR is 1 1. It doesn't affect. It doesn't affect the output because we have only two stable states. We have only two stable states for the SR flip flop, which is known as the set state and reset state, which is known as the set state and the reset state. So the state which is 0 0 and the state which is 1 1, it is not applicable for us. It is not applicable for us. So now in D flip flop, what we are doing? Suppose, let me show you. Suppose in D flip flop, this is my input. Do not consider this. Okay, now we do not have any input like R and S. In D flip flop, we have only single input and it is known as a D. In D flip flop, we have only single input and it is known as the D. It is known as the D. Now what we are doing? So here I am taking the input and connecting a NOT gate and giving the input to the another gate, giving the input to the another gate. So it's the same circuit, but both the input S and R, we are short circuited S and R with inserting a NOT gate, in between. Okay, with inserting a NOT gate in between. So suppose if you are considering this is S also and this is R only. Okay. So suppose if my S is 0, then same input we are taking, connecting with a NOT gate. So at that moment my R is 1. So at that moment my R is 1 and my flip-flop state, the flip-flop state is reset. And suppose consider my S is 1. My S is 1. So at that moment my R is 0. At that moment my R is 0. So at that time my flip-flop state is set. So what we are doing in this, okay, what we are doing in this D flip-flop, we have a two states which application is not there. Okay, suppose we do not require a separate SNR input. In some of the states we require only one input. So the input condition, you can say S is equal to R is equal to 0. So SNR 0 0 and SNR 1 is we do not require that. So it's not required. Okay. SNR 0 0 and SNR 1 1, we do not require those state because when SNR is 0 0, when SNR is 0 0, the state is no change state. So if our state is not changed, so we do not require that state. If our state is no change, then we do not require those state. And for SNR is 1 1. For SNR is 1 1. Our state is, again, you can see in the truth table. Yes, this. If our state SNR is 0 0, if our input SNR is 0 0, then our state is no change. Then our state is no change. So if our output will not change, what is the input? Okay, what was the input? If our output is no change, so we do not require those type of input because our output will not change due to this input. And if our SNR is 1 1, then then this state is known as the invalid state. Then this state is known as the invalid state. So again, we do not require this type of state because when we are giving the input 1 1, when we are giving the input 1 1, SNR 1 1, the state is invalid. The state is invalid. So we do not require the 0 0 and 1 1. We do not require the 0 0 and 1 1. Again, come to the theory portion. Now see here, what is D flip-flop? The D flip-flop, D means data again, okay? D means data. So D flip-flop has a single data input, so we have only one input. So this type of flip-flop is obtained from the which flip-flop? SR flip-flop. And how we are obtaining that? How we are obtaining the D flip-flop from the SR flip-flop? By connecting R input through an invert. And S is directly connected to data input, just I show you like that. S is directly connected with a data input and R is connected with the inverter. Okay, you can see the SR flip-flops are obtained, the D flip-flops are obtained from the SR flip-flop. And how we are obtaining from the SR flip-flop? By connecting the R input through an inverter and the S input is connected directly to the data input. So which state are not there? The reset state and the unpredictable state when the input are same and high. So we do not require in many practical application, we do not require this input condition. We do not require this input condition. So these input conditions can be avoided. This input condition can be avoided by making them complement to each other. By making them complement to each other. Sorry. So this is the D flip-flop. You can see the figure. So this is the D flip-flop. From the figure, you can say this is the D flip-flop. So this is actually my S, and this is actually my R. So we are connecting S and R through a clock pulse, and this remains same. If my S is 1, if my S is 1, my output state is set, and if my S is 0, if my S is 0, my output state is reset. My output state is reset. So this is the truth table. You can see. So we have two possibilities. We have two possibilities. Suppose my D is 0 0. Suppose my D is 0 0. So it is characteristic table. We have to make a truth table. Let me write down the truth table of the D flip flop. Wait for the 1 minute. Okay, so let me write down the truth table. So this is the truth table of the D flip flop. You can see. So we have a clock input. Okay. Another we have a D input. Then you can say it is Qn, and we have a Qn plus 1. And finally we have a state. Finally we have a state. Suppose I am not giving any clock, or you can say my clock is 0 0. You can say my clock is 0 0. Okay. So if my D is either 0, so again D is either 0 or 1. Okay, D is either 0 or 1. If my Qn remains 0, my Qn plus 1 remains also 0. And if my Qn remains 1, my Qn plus 1 remains also 1. Because when we are not applying the clock pulse, when we are not applying the clock pulse, then the state is remains the no change state. Okay, so no change state is the not the uh, no change state is the not the state of actually D flip flop. No change state is come to the truth table because of that when we are not applying the clock pulse, when we are not applying the clock pulse. Okay. So now actual we have two states. Suppose I am giving the clock pulse. Suppose I am giving the clock pulse and my D input is, you can say, 1 1. My D input is 1 1. So if my D input is 1 and my Qn is, what is the Qn is 0, then also my output Qn plus 1. The second state is 1 because my D input is 1, and suppose if my Qn is 1, then also my Qn plus 1 is 1. So when my D input is 1, my output is always 1, and this state is known as a set state. This state is known as a set state, and suppose again I am giving the clock pulses, and if my D is 0, so if my D is 0, so what is your previous state? What is your previous state output? It doesn't affect. Either it will be 0 or 1, either it will be 0 or 1, it remains 0. It remains 0. Okay, it remains 0. So, so when D is equal to 0, my output is equal to 0. And if my D is equal to 1, my output will remains 1. So if D is equal to 0, output is 0. If D is equal to 1, output is 1. So when my D is equal to 0, the state is known as the reset state. And when my D is equal to 1, my set state is known as the set state. Okay. So actually this is the truth table of the D flip flop when we are applying the clock pulse, when we are applying the clock pulse. But if we are not applying the clock pulse to any flip flop, if we are not applying the clock pulse to any flip flop, it remains in the no change state only. It remains in the no change state only. So anyone having any doubt in a T flip flop? Anyone having any doubt in SR flip flop and D flip flop, then you can ask me a question. And if you do not have any doubt, please write down a clear so we will move forward. So anyone having any doubt? See, in a D flip flop, it doesn't different. It is only a SR flip flop only. But what we are doing, we are short circuiting S and R with putting invert in between. Okay, so now the next flip flop is a JK flip flop. But it's having some different combination you can see in your screen. So you can see this is the JK flip flop. It having a clock pulse, but it also having the with a clock pulse, it also having the effect of the previous output. You can see here we are connecting the Q with AND gate. We are also connecting a Q dash again with the AND gate, and here also we are connecting a clock pulse. So let's check the figure first, then we will move forward for the its truth table. Okay, so this is actually a JK flip flop. Okay, it's the flip flop name is JK flip flop. Again, it having a different state. But what is the main application of JK flip flop? If you remember the D flip flop and SR flip flop, when or focus on the SR flip flop in only, when my SNR is 1 1, when my SNR is 1 1, my state is invalid state. If you remember this thing, okay, my state is invalid state. If again I am repeating, if my SNR is 1 1, if my SNR is 1 1, my state is invalid state. My state is invalid state. So here, when my JK is 1 1, instead of invalid state, we have a new state which is known as the toggle, which is known as the toggle state. Okay, so the main problem of the SR flip flop that we have one invalid state. We have one invalid state, so that problem is now resolved. That problem is now resolved. Okay. So here we have a state which is known as the toggle state. What that means? If my output is zero, if my output is zero, what will work in a toggle state? Let me tell you about that. All the other things are remain same. Suppose we have a two input, you can say JK, our clock input is remain plus. So we have two possibilities of Qn and Qn plus 1, and you can say it is a state. So if my J and K both are 1 1, if my J and K both are 1 1, and now if my Qn is 0, so it will toggle from 0 to 1. So my Qn plus 1 is 1. And suppose if my Qn previous state output is 1, then it will toggle to 0. So output is changed from 0 to 1, 1 to 0. So that's why that state is known as the toggle state. This state is known as the toggle state. Okay, all the other thing is remains same. All the other thing will remain same. Let me write down the truth table of JK flip flop. Suppose we are giving clock every time. So we have possibilities that my J and K is 0 0, or you can say my J is 0 but my K is 1, or you can say my J is 1 and my K is 0. So these are the possibilities. And let's say every time we are giving the clock, every time we are giving the clock, okay. And suppose here my Qn is 0, Qn is 1, again 0 1 0. So when my J and K is 0 0, so same as a SR flip flop, same as a SR flip flop, my Qn plus 1 is remain same, which is my Qn, and that state is known as the no change state. That state is known as the no change state. Suppose if my J is 0 and K is 1, so it is same as a reset. So if my Qn is 0 or if my Qn is 1, it doesn't affect the state. The state is known as the reset state. The state is known as the reset state. And if my J is 1, if my J is 1 and K is 0, if my J is 1 and my K is 0, if my Qn is 0, then also it is 1, and if my Qn is 1, then also it is known as, it is work as a 1. So that state is known as the set state. That state is known as the set state. Okay. So we have a set. So J is looks like S. K is look like as a R. J is look like as a S, and K is looks like as a R. Okay. But what is the main application of the JK flip flop? Okay, it resolves the problem of the invalid state of SR flip flop. It resolves the problem of the invalid state of the SR flip flop. So that is the main application. That is the main application of the JK flip flop. And now what is T flip flop? So let me show you in the figure only. Instead of giving two different input, J and K, what we are doing, we are sorry. What we are doing in a T flip flop, we are short circuiting. In D flip flop, we are putting the inward gate in between, but in here now we do not have a J and K. We have only one input, which is T. We have only one input, T, and here T means toggle. Here T means toggle. So in T flip flop, we have only two possibilities of the in a truth table. Which one? First one is this, or you can say 1 1, and second one is this. We have only these two states because we are short circuiting the input. So we have two possibilities only. Either T is equal to 0 0. So what we are getting as an input, both are 0 0. So at that time, my output state is no change. Okay, and suppose my T is 1. So both the input having a 1 1, then my output state is toggle. And that is the main application of the T. That is the main application of the T flip flop. That is the application of the T flip flop. And what is the meaning of T in the T flip flop? In T flip flop, the meaning of T is only toggle, and that is the application. So when we require the toggling input, when we require the toggle to output, then we are using the T flip flop. So again, come to the theory. So you can see this is the JK flip flop. You can see this is the truth table of the JK flip flop. If we are not giving the clock pulse, it doesn't affect. So it doesn't affect. So when my J and K both are 0 0, then my output is remain same. And its state is no change. Its state is no change. If my input J is 0, and K is 1. So when my K is 1, my output state is reset. And suppose if my J is 1 and K is 0. At that moment my output state is set. And when my J and K input both are 1 1. When my J and K input both are 1 1, At that moment, my output is toggle. At that moment, my output is toggle. So if my present output is 0, then it will change into 1, and if it is 1, then it will change into 0. Then it will change into 0. So this is the truth table of the JK flip flop. You can see this is the figure of the T flip flop. Just what is the change in the T flip flop? Just we are short circuiting the J and K both. We are short circuiting J and K both. So we have only two possibilities. The one is for the no change, and another is for the toggle input. Another is for the toggle. Okay. So this is about the SR, JK, T and D flip flop. This is about the sorry. This is about the SR, JK, T and D flip flop. So anyone having any doubt in this, you can ask me a question by unmute yourself, or you can ask me a question in a chat session. So anyone having any doubt? Let me. Sorry, I didn't get your question, Miloni. What's that mean, tricky? It's very easy. Just you have to follow, or you have to know about the SR and JK. So D is made from the SR, T is made from the JK. So you have to focus on these two. This is the main two. So if it is clear, please write down a clear so we will move forward. Okay, so let's move for the pre-test. Now all of you have to give me the answer. The first question is, the trigger pulse is given to change the output of the latches. The output of the latches will remain in set and reset until the trigger pulse is given to change the state. Any pulse given to go to into previous state. They don't get any pulse more. The pulse is at trigger. So either it is A, B, C, or D. I didn't get any reply from anyone. So give me the answer. What is the answer? I am audible to everyone. So I am not getting any reply till now. So let me do one thing. Those who are giving the answer, I will consider their attendance only. So if you require the attendance, give me the answer. Otherwise, you will be absent. Okay. So give me the answer. Either it is right or wrong. It doesn't matter. It doesn't affect. So give me the answer of first question. The output of the lattice will remain in set and reset until the first one is the trigger pulse is given to change the state. Any pulse given to go into previous state. That's also I know, Miloni. Either A or B or C or D. Out of this, one will be the answer. So you have to select any one. And when I think you have a mid-sem in a MCQ, you tick mark all the one. Okay. Then we will check either you are right or wrong. So if you are interested in pre-test, then it will be, then I will consider it. Okay. Otherwise, skip this. This is the simulation. I will share the link of the simulation. I am not ignoring anyone. Now I am not interested in a pre-test and the post-test. Do the simulation, finish the lab. I will ask everyone today to share your screen. So those who are sharing their screen, I will mark present of them. Plus, because no one is interested to give the answer, so I am also not interested to give the to for conducting the pre-test. It is not for me. It is for your practice. I know the each and every answer. Okay, and no one is interested to give the answer, so I do not want to force everyone to give the answer. Because when I am asking the question, I think I am forcing you to give the answer. Okay, so let me finish the pre-test for you, for your knowledge. Generally, I got the two answer from the question one from the Milonin, another from the Henil, which is A. So let me tick mark the A. What is other? The second question, what is the trigger pulse? So the options are a pulse that starts a cycle of operation, a pulse that reverses the cycle of operation, a pulse that prevents a cycle of operation, and a pulse that enhances a cycle of operation. So actually, what is a trigger pulse? So trigger pulse is actually, yes, Milon, it's a pulses that starts a cycle of operation. When and when we are given the triggering, or when and when we are giving the uh, a clock to the flip flop, then and then it starts the operation. Then and then it starts the operation. So the A is the answer for the second question. Now third one, if Q is equal to 0, if Q is equal to 0, the output is said to be set, reset, previous state or current state. Okay, so most of you are giving that answer is set. The sequential circuit is also called a flip flop, a latch, a strobe or a adder. Okay, so Parthiv gives the answer, Miloni, Kisan gives the answer, it is B. Okay. Again, Nishita, Dirga, Keyur and Henil also gives the answer, it is B. The basic latch consists of two inverters, two comparators, two amplifiers, or two adders. Okay, so Parthiv, Kisan, Nishita, Keyur, Dirga, Mitul, Kusal gives the answer, it is two inverters. Keyur also gives the answer, Sanjna. So let me submit the quiz. So yes, it's all question is right. Okay, so I already shared the link with everyone of the simulation. Please start the simulation. Okay, just you have to verify the truth table. Let me show you the SR flip flop. So again, we have give the supply to the each and every IC. So you can see here, if my SNR is 00, then my Q is 0 and Q bar is 1. So now again, when we are changing the SNR, you can see here, if I am changing the SNR, it will doesn't change the output. Why? Because not we are not giving the clock pulse. We are not giving the clock pulse. Suppose now I am giving the clock pulse. So add to the table, my clock is 1, my SNR is 00, so my output is not changed. Suppose my S is 1, add to the table. Okay. In each and every time we have to apply the clock. Then it is known as the set. Suppose my S is 1, R is 0. Again I am giving the clock. Sorry, it's both are 1 1. Then it is the invalid state. And suppose my S is 0 and R is 1. I am giving the clock and add to the table. Then it is, sorry, S1 already, S0 and R1. S0 and R1, if we are giving to the input, then it is known as the reset. Then it is known as the reset. Okay, same way you have to simulate all the others. And in simulation, if you finding anything, you can ask me a question either in chat session or you can ask me a question in a unmute yourself. Okay, so take a time of 10 minutes or 10 to 15 minutes and simulate all the thing. Okay, so I think almost all you are uh, performing the experiment. So because I didn't get any query, so let's move for the post test. Okay, so this is the question number one. Which of the following is correct for the get D type of flip flop? Getted D type of flip flop. The Q output is either set or reset as soon as the D input goes high or low. The output complement follows the input when enabled. Only one of the inputs can be high at a time, and the output toggles if any of the input is held high. Either it is A, B, C, or D. Okay, Henry gives the answer D. Miloni also D. Harshit A. Okay, Kisan Kevu D. But see, let me tell you about this. The answer of Harshit, okay, Dirga also gives the A. I think it is right. Why? Because in D flip flop, we do not have option of toggle. Toggle is the option of toggle will become in a JK flip flop, or you can say T flip flop. The D flip flop having only two states, set and reset. Because what we are doing, we are short circuiting the SR flip flop by putting invert in between, by putting in invert bit. Okay, it's okay, Miloni. So we do not have an option of toggle. Toggle is come under the JK flip flop and T flip flop only. Okay. The next one, a basic SR flip flop can be constructed by cross coupling of which basic logic gates. So SR flip flops are made by which of the following basic logic gates? Either we are using AND gate or gate, or we are using exclusive or exclusive NOR gate, or you can say NOR or NAND gate, or you can say AND or NOR gate. Okay, so Parthiv, Henil, Miloni, Harshit and Mitul gives the answer C, and it is correct because if you see the figure, we are using the cross coupling of basic SR gate. In basic SR gate, we are see basic SR gate, we are cross coupling the NAND gate, or we are cross coupling the NOR gate. So final answer is C. Next one, the truth table for an SR flip-flop has how many valid entries? Has how many valid entries? 1, 2, 3, or 4? Okay, Parthiv gives the answer. Miloni gives the answer. Henil is not sure. Miloni is not sure. And Harshit Dirga gives the answer C. So most of you are giving the answer C. Let me tick mark the C. The third one, the flip-flops which has not any invalid state. So which are the flip-flops out of this which do not have any invalid states? SRJKD, SRJKT, JKD, SR, JKDT. Okay, so Parthiv, Keyur, Henil, Harshit, Sanjana, Mitul gives the answer. It is D. Let me tick mark the D. So both JK and T flip-flops are derived from the basic, which basic flip-flop? SR flip-flop SR latch, D flip flop. So either A, B, C, or D. Okay. Harshit gives the answer C. Parthiv gives the B. Miloni thinks C. Anil again having a doubt of C and B. So let me tick mark B. Click on submit the quiz. Okay. All the questions are right. Okay, it's okay. It is just only lab. We also cover this all the topics in theory session also. At that moment, I think your doubt will be clear. So thank you everyone. And again, today we have a lecture because we got the mail from the your class coordinator that your session of Indian Constitution is cancelled. So we have a lecture at 1. So we will meet at that time. Okay. So thank you everyone for attending the session. Please write down your enrollment number for the attendance. Yes, Anil, what's your doubt? What is the urgent thing? So please write down your attendance, and those who are already write down their attendance, if they want to leave, they can leave the session.